All right, so what we're going to do is we're going to start on the part where you normally put the glue, right? That part that's blank. Draw a parallelogram, kind of as big. Doesn't have to fill the entire thing, but you want it to be big because we're going to label this. It doesn't have to be pretty because in the end you won't be able to see it because you're going to put glue on it anyway. But we're going to discover some things here, and then it'll be done neater on the notes itself and kind of all split up. All right. So tell me first then, what makes a parallelogram a parallelogram? Can anybody tell me that? Good. Two pairs of parallel sides. So your opposite sides are parallel. And that's what makes a parallelogram a parallelogram. Then there are properties that go along with it. And all of the properties are things that you can figure out based on stuff you already know about geometry. So first thing we're going to do is we're going to look at, I want you to think without speaking about this set of angles here, these two angles, about what type of angle pair that is. Okay. All right, Ruben, what type of angle pair is this? Same side interior angles. Y'all agree with that? Yes, very good. So then what does that tell you about their measures? Good, they're supplementary. Good. So these two angles here, not necessarily congruent. Sure, it's possible, but supplementary. So I'm going to mark them different. And I want you to think again, without speaking, about these top two angles and what type of angle pair those would be. Savannah. Okay, so what type of angle pair would these two angles here be? What do you think? I also need your homework. These two right here. What type of angle pair do you think those are? Same side interior. Do you agree with that? They're also same side interior angles, just different sets of different parallel lines and different transversal. So if these are same side interior and these are same side interior, which means these are supplementary and these are supplementary, then what do you think is true about these two angles? They're congruent. Okay, good. So these are congruent and these are congruent. So if you know that you have a parallelogram, then your opposite angles are congruent. Okay? Kelly, you have your homework? This one? You need to have that. All right. Now the next thing we're going to do is we are going to draw in one of the diagonals. So draw one in. All right, so the diagonal cuts the triangle into two what? I'm sorry, that doesn't make any sense. I sort of gave it away. The diagonal cuts the parallelogram into two triangles. Okay, duh. Do you think that these triangles are congruent? Yes, probably. Do you have any way to prove to me at this moment that that is true? How? Angle, angle. Is angle, angle prove that they're congruent? No. Proves that they're similar, but I actually don't have angle, angle in the triangles because I split these angles and I don't know that I necessarily bisected them. But let's look at what we do have. We know that this is congruent to itself, right? Then if I look at the top and the bottom as my parallel lines and this diagonal as the transversal, then is this angle right here congruent to any angle that we have? Yes, I've got what kind of angle pair? What would this? Alternate interior angles. Very good. So these two would be congruent, right? So then, is that enough to prove that the two triangles are congruent? Look at what we have. Do you think that I can use one of the properties to prove angles congruent? Angle, angle, side. Angle, angle, side, right? Angle, angle, side. You with me? So if I know that the two triangles are congruent, which they are, then everything about them is congruent. Like all I have is two angles and a side that I have so far, but I know that then these have to be congruent also, which I really knew before I said the triangles are congruent, right? We could use the third angle theorem or something like that. And this, of course, is not officially how you actually label angles, but I'd have to have so many arc marks that we'll just pretend like this is okay for now. So all three sets of angles are congruent, but all three sets of sides are congruent as well, which means that this side is congruent to this one, and this one is congruent to this one. Okay. So if I have a parallelogram that I know that the opposite angles are congruent, it gets cut into two congruent triangles, and opposite sides are congruent. All good with that so far? All right, so now we're going to draw in the other diagonal. Let's draw in the other one. It's actually not a kite. Kind of looks like a kite, but a kite has a totally different set of properties that we'll discuss next week. Because a kite actually is a geometric figure, if you didn't know that. So. All right, so now I've got both of these diagonals in here, which, do you think that the diagonals are congruent? Do you think they would be? No. They can be, just like, the angles can be congruent and stuff like that, but in general, they're not. So and if you think about it, if you're unsure, and you're like, well, I don't know, maybe in a different picture they kind of look like it, but you're not sure, just think about it like this. I mean, if it's just kind of slanted, then you might be thinking, I'm not sure, maybe it is, maybe it isn't. But remember, it could be like really slanted. And then if it's like that, it's a little bit more obvious that the diagonals are not going to be congruent. Right? Again, they can be, but it's not a given every single time. So they're not congruent to each other. But it does create 4 little triangles now. And we know that these two angles here are congruent. Why? Vertical angles. And these two angles are congruent because of vertical angles. And I know I used 2 arcs, even though these are not congruent to these, but again, we'd have like 1,000 little arcs on here. So I have these 2 sets of angles. Does that give me any other congruent triangles? Like, could I say that these 2 triangles here are congruent? Yeah, angle, angle, side still, right? Blue, green, orange, blue, green, orange, right? And then the same, so these 2 triangles here are congruent, and these 2 triangles here are congruent. So if the triangles are congruent, then again, everything about them is congruent. So since these 2 are congruent, that means that this piece is congruent to this piece, and this piece is congruent to this piece. So knowing that, then I can say that the diagonals do what to each other? They bisect each other. Okay, so that's yet something else about a parallelogram. Okay, we all good so far? So do you see how all that stuff really is something that you can come up, if you're not sure about a property or you think it is, but you're not sure if it's right, if you know congruent triangles and parallel line properties, then you can reassure yourself that things are true. Okay, we good? Any questions? All right, so let's go to the actual notes part of this then. This is going on page 95 and we're done. And I know parallelograms are not brand new to you. You know what they are, but I don't think you've done very much with them or really talked a whole lot about their properties and stuff, even though you've probably known what is for a while. This is the definition. Okay, because we're going to have to understand the difference between the definitions and the theorems here. But the definition is a quadrilateral with 2 pairs of parallel sides is a parallelogram. So that's the definition. Everything that we talk about through here is going to be a theorem. So along the side you can write theorems. So you know that that's kind of that's what all those are. Just write theorems on the side. It doesn't actually say that. The definition tells you what a parallelogram is. And then notice that these all start with some version of if a quadrilateral is a parallelogram, if a quadrilateral is a parallelogram, if a quadrilateral is a parallelogram. So in order for all these things here to be true, what do you have to know? That the quadrilateral is a parallelogram, right? So this stuff here doesn't work unless you know you have a parallelogram. And the only way right now you know you have a parallelogram is if you can say either that they told you it was a parallelogram or that 2 pairs of opposite sides are parallel. Make sense? And we're going to have to justify with definitions and theorems and stuff, so we're going to abbreviate some. And so the way we would abbreviate this definition is if it is a parallelogram, then it has opposite sides parallel. But here's the thing. If you remember when we talked about conditional statements and stuff and good definitions, a good definition can be written as a biconditional. So if it's a parallelogram, then it's a quadrilateral with both pair of opposite sides parallel. And if it's a quadrilateral with both pair of opposite sides parallel, then it's a parallelogram. So since it works both ways, the biconditional had the arrows pointing both ways. So on the definitions, the arrows point both ways. The theorems, most of the time, just point in one direction. Okay? That's why we'll have a converse of a theorem or something. All right, so let's look at this first one. We've got, it says, if a quadrilateral is a parallelogram, then its opposite sides are what? I've already come up with all this. Congruent. They are parallel, but that's the definition. This is the definition is the opposite sides are parallel. The theorem tells you that the opposite sides are congruent. Looks like this. So the way we would abbreviate that is, if it's a parallelogram, then opposite sides congruent. And you use the little symbol for parallelogram, kind of like we had a little symbol for a triangle. You don't do it for a pentagon and hexagon. We don't draw 1,000 little lines or anything. We actually use the words, but for parallelogram we use that. So what we know here then is that line segment AB is congruent to CD, and we know that BC is congruent to AD. Everybody good? All right, so then, again, if a quadrilateral is a parallelogram, so I know I have a parallelogram, then the opposite angles are what? Congruent. Opposite angles are congruent. Good. So A is congruent to C, B is congruent to D. So I can abbreviate with that with, if it's a parallelogram, then opposite angles are congruent. And that means that angle A is congruent to angle C, and angle B is congruent to angle D. Okay, everybody good? All right, so the next one. If a quadrilateral is a parallelogram, then its consecutive angles, so remember, consecutive is one right after another. A and C are opposite, but A and B are consecutive, and how are they related? They are supplementary. Good. And they're supplementary because they're same side interior angles, but they are supplementary. So I can say then, okay, thank you. You're leading, and so here is your homework. Okay. All right, so there's not really a great way to label anything, to label that they're supplementary, unless we made up numbers or something, but we don't need to. So we can just say, if it's a parallelogram, then consecutive angles are supplementary, which means they had to give me 180, so all four of these are 180 degrees. Okay. Now, this next one doesn't actually start off by saying if a quadrilateral is a parallelogram, but it says if a parallelogram has, so clearly you still have to have a parallelogram. And we didn't directly talk about this one with that picture, but the things we did talk about can help us here. It says if a parallelogram has one right angle, then it has blank. All right, so let's say that angle A is a right angle. Then what can you tell me about angle C? It's congruent to angle A, so it has to be a right angle, right? And then what can you tell me about angle B? It's a right angle because these have to be supplementary, right? So then what can you tell me about angle D? It's a right angle, either because of consecutive angles or opposite angles, it doesn't matter. But instead of me having to explain all that stuff every time that might come up, I have this theorem that says if a parallelogram has one right angle, then it has four right angles. Yeah, three other ones, but yeah, but four right angles. So you'd only have to label one of them, and that forces the rest of them to be right angles based on the properties of the angles. So this one doesn't abbreviate quite as nicely as the rest, but if it's a parallelogram, if a parallelogram has one right angle, then four right angles. So our conclusion here, if we started with A, is that angle B, angle C, and angle D are right angles. All right, so then we're back to, if a quadrilateral is a parallelogram, then its diagonals do what to each other? Bisect. Good. So the diagonals bisect each other. So these two pieces are congruent, these two pieces are congruent. So if it's a parallelogram, then the diagonals bisect each other. Okay. Remember, the diagonals themselves are not necessarily congruent. So all four pieces could possibly be congruent, but that's not the norm. All right, so then BE is congruent to ED, and AE is congruent to EC. Everybody good? Any questions at this point? I'm just kind of repeating what we did, yeah, on the big one. I thought it was easier to do it all at once than individually with each one of these because these were harder to label. All right, so again, if a quadrilateral is a parallelogram, then each diagonal divides the parallelogram into two what? Triangles. What's true about those triangles? Congruent. Good. Into two congruent triangles. This one really doesn't abbreviate very well. But if it's a parallelogram, then the diagonal divides parallelogram into two congruent triangles. So that tells us then that triangle ABD is congruent to triangle CDE. Okay. Any questions at this point? Okay, so what I want to make sure that you understand is that all of these properties apply to any parallelogram that exists ever. And a rectangle is a parallelogram. A rhombus is a parallelogram. All right, a square is a parallelogram. So a rectangle, rhombus, and square also have all of these properties plus more. So when we get to those and we start talking about them, we don't have to repeat all of this stuff, but it is important that you understand if you can tell me something about a rectangle when we get there, is that a parallelogram property or a rectangle property? Because it has both, and if you can keep them straight, then parallelograms in general will make more sense to you. Okay, we good so far? All right, so let's look at this. So example 1 says, ABCD is a parallelogram, find each measure, state the theorem or definition that supports your answer. All right, so we're going to start off by looking for line segment AD. Most all of the time, when a question asks you to state your theorem or definition or to justify your answer, that almost always comes last in the question. But really it should be something that you do first, because if you can't come up with that, then you don't know how to work the problem. Because the theorems give you the properties, and then the properties tell you how to work the problem. So I think sometimes you'll work these problems and you're like, I just never know what to say to justify. Well, actually you do. It's the reason that you knew how to do what to do, or how you knew what to do. That's what I was trying to say. So if I'm looking for AD, tell me something about AD in this problem. It's congruent to BC, right? And you know that because if it's a parallelogram, opposite sides are congruent. So there's your reason right there. So we'll just go ahead and write that down. If it's a parallelogram, then opposite sides are congruent. There's a whole lot of other things that are true, but none of them help me with AD. That's what's going to help me figure out AD. So since that's true, I take 7x, set it equal to 5x plus 19. Then it's a piece of cake, right? 2x equals 19, so x equals 19 over 2. All right, they didn't ask me for x, so I got to plug it back in. So when I do that, I'm going to get 7 times 19 over 2. Okay, so let's talk about this before we actually do this. Little side note, on Monday when y'all weren't here, we had to meet with our content teams, but I met with, basically we met as an AP team. So I met with the pre-AP Algebra 2 teacher, the pre-AP Pre-Cal teacher, AP Calculus teacher, and the AP Stats teacher. And we sat around and talked a lot about while we teach, how we need to teach it so we're all doing the same or whatever. But consistently across the board and from your calculus teacher, and I know you might be thinking, okay, I'm not going to take calculus, so he's not going to be my teacher. That's fine. But you might have to take it in college. You will probably take some sort of math in college, and it's going to be a whole new world for you. Your professor, depending on the course, will probably not let you touch a calculator at all, and you won't get to redo and redo. And if you can't do your basic computations pretty simply, it's going to be a problem for you. So you've got to be able to manipulate these numbers quickly, because a lot of you have trouble factoring because you don't know the factors of the numbers themselves, because you don't know how numbers relate to each other. So instead of worrying about, oh my gosh, it's a whole number times a fraction, we better be past that first of all. So we know we got to multiply 7 times 19. There's no reason to come off to the side and do 7 times 19. Now, I'm not saying you have to do everything in your head, but there's a lot of stuff that you could do quickly and easily that some of us make out to be way more complicated than necessary. You probably don't just know what 7 times 19 is. That's okay. What's 7 times 20? 140. That's easy, right? Because it's like 7 times 2 and you put a 0 on it. So it's 140. Now, I know, if nothing else, that's not the answer because I didn't want 7 times 20 when it's 7 times 19. But 7 times 20 is easy. That's 140. So what do I do with that 140 to get the number I really want in the numerator? Subtract 7, because I didn't want 20 of them. I only wanted 19. So it's easy to use the 20 and take 1 away. Does that make sense? Kind of how they're teaching somewhat Common Core-wise, or at the lower levels, the crazy stuff they're teaching in elementary school now. It's not really that crazy. To me, it's crazy to teach as an initial learning, like in elementary school. I don't know that that's the best way to teach things. But a lot of those things that seem so wacky that they're doing at the lower grades still shouldn't be done at the lower grades. But that's the way you kind of need to be thinking about things now, like to have a good understanding of how numbers relate to each other. So if I do 7 times 20 and I get 140, I subtract 7, what does that give me? 133. And I put that over 2. That's an odd number, so I can't do anything with it, and I'm done. And isn't that way easier than going off to the side? I don't even care if we know what 7 times 9 is. I mean, we do care and we need to know, but it's easier than doing that. We good? Okay, awesome. So next one, we're looking for the measure of angle B. All right, well, tell me about B in this problem, in this particular one. What do you know about it? Supplementary to A. It's congruent to D. Opposite angles are congruent, right? That didn't get me anywhere because I don't know anything about D. But these are what kind of angles, parallelogram-wise? Consecutive. Good. They are same-side interior angles with parallel, but they are consecutive angles. That's how it goes with our parallelogram. So we can say if it's a parallelogram, then we know the consecutive angles are supplementary. And since we know that, we know how to set it up. We say 6y plus 5 plus 10y minus 1 equals 180. So that's going to give me 16y plus 4 equals 180. So 16y equals 176. I've also found that some of us, I don't know if you don't have a good concept of division or you're scared of division, but in a situation like this, I see people guessing and checking. I'm going to pick a random number, multiply it by 16, see if it gives me 176. That's usually a waste of your time. Okay? How many times does 16 go into 17? Once. With how much left over? 1. And then 16 goes into 16 once. So y is 11. Then if you want to check yourself, that'd be great, but that's better than, okay, let me try 8. Oh, no. Let me try 9. Well, let me try 12. Let me jump. Nope, got to go back down. And you're just there all day long multiplying when that's totally not necessary. So y is 11. Now I've got to plug it in, so that's going to give me 6 times 11 plus 5. 6 times 11 should be a piece of cake, right? 66 plus 5 gives me 71. So yeah, 71 degrees for angle B. The work itself should be super easy. It's just a matter of justifying how you know you get to do that. Okay. Questions? And in Schoology, you're putting both in. But the way I had to do it is there'll be 2 number 1s and 2 number 2s. So basically you put in the numerical answers, and then the next number 1 or the number 2 or whatever, then you put in the reasons, and you're not typing them in. It's a matching thing, and if you've never done that in a Schoology assignment, you click on the one you want, and then you click on the blank, and it puts it in there. So you're not actually typing the words. Does that make sense? So you don't have to worry about how do I abbreviate that? How do I have to word it? What if I leave out a word? You don't even have to worry about misspelling. You just click, click. okay? So just don't make that harder than it is. And if you feel like, in some situations, if it takes more than one step, you may feel like there's more than one explanation as to how to get the answer. You know, sometimes if you have a lot of information, there's more than one way to work the problem, which means there might be more than one theorem that applies. In some of those cases I put more than one answer is the right answer, but if yours is counted wrong, but you're like, no, look, that is totally what I used, and you can justify it, then please come justify it to me. That's one thing that you need to learn how to do, and I want you to do. If you can, I want you to fight for your answer, and if you can prove to me that that's what it is, then that's what it is. And unfortunately, sometimes there's so many different answers. I didn't think you would think about it that way, or whatever. But if, or then if it doesn't work, then it's a good conversation that we have, so I can explain to you why it doesn't work, so that you can understand things better too. So, you know, fight for what you think is the right answer. All right. So now example 2. We're just going to go through these. I think I'll run out of time if I give y'all time to work, so I think we'll just work through it together. So we know it's a parallelogram. We're looking for angle W. Well, we know consecutive angles are supplementary, but that's not going to help us here, right? Which theorem is going to help us here? The opposite one, right? Yeah. If it's a parallelogram, then opposite angles are what? Congruent. So 6n minus 2 equals 5n plus 16. So that means that n equals 18. I'm looking for W. So 6 times 18 minus 2. So what's 6 times 20? 120. That should be easy, right? Then what do you subtract? 12, because you had 2 extra 6s, so you subtract 12. So 120 minus 12 is 108 minus 2. So the measure of angle W is 106. And there's other ways to do it too. You can do 6 times 10 and 6 times 8 and add them together, if that makes more sense to you. I mean, different people prefer different things. Or understanding both ways, and depending on the problem, you choose which way to do it, you know, whichever way is easier to manipulate the numbers. Any questions at this point? We good? It's pretty basic. All right. So example 3. Find the values of x and y in the parallelogram. State the theorem or definition that supports your answer. So the things that are labeled in this picture are what parts of the parallelogram? The diagonals. And what do we know about the diagonals of a parallelogram? They bisect each other, which means these 2 pieces are congruent and these 2 pieces are congruent. So that's what I'm going to have to use. So I can say, if it's a parallelogram, then the diagonals bisect each other. There's my justification. So then I set it up. I can say that y equals x plus 3 and y plus 7 equals 3x. And what do I have here? A system. Okay, and do you think that this system would be easier to do substitution or elimination? Substitution. It's a matter of opinion, but if you had to do elimination, or if you wanted to do elimination, you'd have to move things around, and it's really nicely set up for substitution because it's set equal to y. So I can just take this and plug it in for y. I'm going to get x plus 3 plus 7 equals 3x. So x plus 10 equals 3x. 10 equals 2x. X equals 5. So then I also need y, so I've got to plug this back in here. So this gives me 5 plus 3, which means y equals 8. And remember that this step here is necessary. It may seem ridiculous, but without it, it looks like you just made y up, right? You got to have some sort of process. You didn't have to show all of the steps I did right here. Like if you want to skip a step there, all that's fine. But you got the setup and you got the answer at the very least. You got to have some sort of setup. And sometimes the setup or the process part, it looks ridiculous because you're just writing down that you're adding 2 numbers. But that could be worth a point or worth something, so you don't want to miss out on it for sure. Okay. Everybody good so far? Okay. All right, so then this next one says, 3 vertices of parallelogram JKLM are these 3 points. Find the coordinates of vertex M and state the theorem or definition. All right, so let's start by plotting these points. So you'll just go ahead and do that. 3, So what we have is we have 3 of the 4 vertices. So do you think the fourth vertex is going to be in, which quadrant do you think it's going to be in? Okay, I heard 4. Do we agree with 4, or do we think it might be something else? If this is going to be a parallelogram, wherever M is, KL is going to have to be parallel to JM, right? So it's got to be parallel like this. But M could be here. Could M be down here? Yeah, because I could have a parallelogram like that, right? So I could either like have it down here somewhere or over here somewhere. But only one of them is the right answer. And how am I going to know which one it's actually the right answer? The order, exactly. The order matters in the name. JKLM. So JKLM would have to be over here. If M was over here, it would be JMKL. Does that make sense? So it could be in 2 different spots, but the name tells me where it's got to be. It's got to be in quadrant 4. That's at least something that I need, right? So do you think that we could figure out where it is before we did any work at all? Kind of by counting, yeah? To get from K to L, I would have to go up 4 and over 4. So if I start at J and I go up 4 and over 4, I can get to K. And that would be, oh, M, thank you. I'm making up letters here. Be helpful if I use the right one. M, which is at, what does that make it? 7, -4. Y'all count and make sure I'm right. Now here's the thing. If you have to justify how you found that, counting is not ever a justification, right? So to show, what's the only way that we know for sure we have a parallelogram? Opposite sides are parallel, right? If the opposite, I could do distance and show that the opposite sides are congruent, but that's not what tells me I have a parallelogram, right? I have to have a parallelogram, then I know the sides are congruent. Does that make sense to you? So really parallel is my only option. So I can connect these. Let's connect these just so that we can see our parallelogram here. And I got to find slope, right? And we've decided what we're going to use, and that's the opposite sides being parallel. So we'll write down our reason right now. If it's a parallelogram, I got to get out of the way. Drawing here. There you go. If it's a parallelogram, or it's a parallelogram if and only if, right? Opposite sides are parallel. So there's my justification, but then I got to show that they're parallel, which means I have to find the slope. I don't get to just say what it is either by counting. You have to actually show what it is. So when we'll start with KL. So that's going to be delta y over delta x, which would be 6 minus 2 over 2 minus a -2, which will be 4 over 4, which is 1. And by itself, that doesn't really mean anything. So then I'm going to use JM, and that would give me -4 minus a -8 over 7 minus 3. That's also 4 over 4, which is 1. So what you've just shown is that the slopes are the same, therefore these are parallel. Is that enough? How many opposite sets of opposite sides are parallel in a parallelogram? 2. How many sets have you shown? 1. So we got to do the other set. So KJ, that would be 2 minus a -8 over -2 minus 3, which is going to give me 10 over -5, which is a -2. And then LM, which is going to be -4 minus 6 over 7 minus 2. That's -10 over 5, which is also a -2. So I've just shown that these are parallel. So I've shown that they're parallel, which is why I get to say that makes it a parallelogram. But I also need to answer the question. I know we put the point on the graph, but just labeling stuff on the graph isn't answering the question. So point M is at 7, -4. And we've justified why we know that for sure. Any questions? Why do you have to do the process? Because you're telling me that you know that the point goes here, because if it's a parallelogram, the opposite sides are parallel. So you have to show me that they're actually parallel, and that's why that point works. Does that make sense? It's a good question. Anything else? All right. So down here then, in our little summary, things that we know about parallelograms. First of all, we know that opposite sides are parallel, and that is from the definition. Okay. What else do we know? Okay, I heard opposite angles are congruent. So somebody else tell me something different. I think I heard some other things at the same time. What'd you say, Ruben? Because opposite sides are congruent? All right, somebody different, give me something else. Good, thank you. Consecutive angles are supplementary. Somebody else give me something else? Good. So, one right angle, then 4 right angles. That's good enough to. Good. What else? Okay, good. Diagonals bisect each other. All right, and then one more. Somebody hadn't given me something. Very good. 2 what kind of triangles? Congruent. Good. Diagonal divides parallelogram into 2 congruent triangles. All right, so the fact that the opposite sides are parallel, that's the definition. All of the rest of this are theorems. And you can't use these theorems unless you know for sure that you have a parallelogram. Does that make sense? Okay, we good? Any questions at all? Awesome. Then go ahead and glue that in.